having the same management. That is could be very easy. When the management runs different institutions at different locations, the merging or forming the cluster is relatively simple to put forward the academic and physical resources for optimal use and offer multidisciplinary education. The managing trust or society of the institution should submit an undertaking to the effect that institution under its management will merge in accordance with the rules of the, as you know that at present there could be the state government guidelines, affiliating university or regulatory body. But this is the scheme which is coming up for merging of institutions under the same management. But another category, merging of institutions run by different management, will have to come together for the common interests, and then with the approval of the, at present if it is affiliating university, come together with the appropriate provisions in the collaboration or in the MOUs. And there could be very important that adding the new departments, integration and creative combination of humanities, languages, social sciences, arts with science, technology, engineering, mathematics, professional, technical, vocational is requirement, and hence every institution should have institutional development plan in order to offer more and more academic offerings in multidisciplinary education. And hence every institute will also have education department in, and of course giving more and more impact on educational technology. And it is said that all PhD scholars should take up the education program related design, pedagogy, education areas, communication, writing, to make a good skill as far as the teaching is concerned. What is the role aspect? One is about the parent university and state government. As you know that we have different universities at present affiliating, having affiliated colleges. So basically the affiliated colleges should be encouraged cluster of the colleges through collaboration. So they are encouraged to form the collaboration in order to overcome their weaknesses. And state government will actually, given the size of the higher education system and variety of higher educational institution, we have to create the ecosystem where HEIs can plan to become multidisciplinary education, a hub and spoke model where certain number of HEIs will be identified as hub institution and transform them into multidisciplinary education. These hub HEIs can in turn develop a specified number of spoke institutions. And over the same time, they will also be rapid multiplier effect, so that by 2030, there will be at least one multidisciplinary HEI in every district. This is what is planned. And there could be grievances, but there is a mechanism that will be installed along with this clustering, MOUs, merger. Grievance redressal mechanism will be also placed will be also developed in place. As it is said that this is of course linkages, multidisciplinary research clusters, collaborations, collaboration with clusters, with government as well as industries are the way forward. As far as the case study with MGM University is concerned, we know that we have institutions spread over, and they are affiliated to different universities such as Swami Ramananda Tirtha Marathwada University, Dr. Babasaheb Ambedkar Marathwada University, University of Mumbai, University of Health Sciences Nashik, Technical University Uttar Pradesh, that is APJ Abdul Kalam Technical University, MGM Institute of Health Sciences. We have one deemed university. We have also colleges affiliated to Vasantrao Naik Marathwada Krishi Vidyapit. We have MGM University, and we have of course college affiliated to Dr. Babasaheb Ambedkar Technology University. So that means our institutions are now way forward, that we have to now identify that once these institutions are affiliated to different universities and they are looking at creating the clusters, now how it can be done. So it can be like clustering of the colleges. The colleges which are under the same trust can form the cluster at maybe Nanded, or merging of the colleges, or creating the degree awarding autonomous institution status by good grading in NAC, or collaboration of the colleges or becoming constituent part of the university. That means these are the options that will be available to the institutions to collaborate with the concerned university or becoming constituent part of the colleges of the university. And hence, when we talk about why this is need, because there could be 50% rise in gross enrollment ratio. And of course, that will enhance not only employability, but also, of course, skills and entrepreneurship development, and also research and innovation, better global ranking. That means when we share the facilities by coming together by the way of clustering or MOUs or mergering or expansion or becoming part of university, so it comes under effective utilization of resources, governance, and separation of powers. So basically, the concept is it's not only that the universities may get requests from different colleges to become a part of university in future. Not only the colleges under the same trust, but also the colleges which are unable to develop themselves into autonomous degree granting colleges will come together with us to form cluster to become part of the university or to also have the collaboration. And hence the way forward is to have already identified and start working for creating the clusters so that we can not only achieve the good ranking in global ranking, QS ranking or NIRF ranking, and also improved our gross enrollment ratio substantially by offering multi academic offerings. This is how the way forward, and as Gandhiji said, in a gentle way you can shake the world. So this is the gentle way that we can bring together not only the knowledge but also the facility faculty to create multidisciplinary educational system and research as well. Thank you so much.
Thank you so much, sir, for providing the roadmap and also showing us how MGMIHS, through its institutes, can collaborate and form clusters with the other institutes nearby. Thank you so much. We now proceed to the panel discussion. And we have about 10 to 15 minutes for the panel discussion. And if anyone has questions, I request you to raise your hand. We'll provide you the mic for asking questions. Meanwhile, we already have 2 questions in the chat box. And for this, I invite Dr. Bhavna Junagade to help me. She is the Associate Professor of Anatomy and Criterion 1 in charge, University IQAC. Over to Bhavna, ma'am.
There is one question for Dr. Sushanta from Dr. Ravi. If a university decides to remain as uni-disciplinary university, what will be the age? Will it be closed or derecognized or the government someday will it become a
Question.
Ma'am, can you please repeat the question? We are not able to listen to the question.
Yeah, okay, we'll a little slower, please.
Can you hear me now?
Sir, we would like to repeat the question. The participants want to know.
Hello. Good afternoon. This is very valid and important question. If the passage of the time and the flow of the journey and if that is implemented in a true spirit, that is by giving the autonomy to the all educational institutes, the government is not going to decide the fate of the university by creating only the students that are coming to the university, they will decide the fate of the university. If the students are taking education to such a single disciplinary university, they will surely not come to the university or join to the university. The university will die. That will be decided by the students. But National Education Policy 2020 should be implemented be implementing. Then only this is not one way for the future. There may be other possibilities. Suppose I want to join anything on this issue.
I'm sorry, sir, I could not get the clarity from the question. So if madam can read out the question, then I can respond to it.
Okay, sir. If a university, the question is, sir, if a university decides to remain as a unidisciplinary, what will be its fate? It will be closed or de-recognized, or government will compel it to become multidisciplinary.
Okay. See whether what government thinks or what is the regulation. Instead of that, we have to understand the need of learner and development of education and research. Now, we have to develop the learner with multidisciplinary sets of skills: aesthetic, social, moral, social, emotional. That means 21st century set skills should be imparted through education, and that is possible through multidisciplinary education. So that means the student should be able to learn across the discipline, and hence one should not remain restricted to only one discipline. It is always beneficial for entering into, as you know, that everywhere, if you see across the world, every branch of study is getting connected with different applied branches which are correlated, and hence it is the era of multidisciplinary education, and one should not have also lot of boundaries or restrictions among the discipline itself. One should give option to have more and more options to learn from different disciplines. So there is it may not be a good idea to maintain a single discipline or single subject university or institute. Thank you.
Sir, Sabkal sir, there is another question for you from Dr. Praveen Shingari himself. The question is, there is provision of merger of different institutes of same management, but is there a provision of merger of two universities under the same management in NEP? If yes, what will be its benefits?
Madam, universities come in existence to offer multidisciplinary education, and in fact, see, there is no need to merge two universities, because they are basically, they can come together as collaboration and sharing the strong their competency. So there is no need to merge the two universities. In fact, we can have more and more institutions coming to the university as a constituent unit or between the two departments. But what it is mentioned that different university in the same management, they can merge into the different universities of the same management. See, for example, we have two universities. So, and medical university has to become multidisciplinary university. And the institutions in Mumbai can merge into this university. And the other institutions in this part can merge in MGM University, Aurangabad. This is the future picture of reclustering, or if some institute wants to become degree granting autonomous institution, it is a very good phenomena. So basically, we have to assure our own standards of quality, and in terms of, then only this quality is recognized by way of what you call international ranking. So that will be the great idea for now new architecture of the institution. Thank you. There is one more question. Can I reply?
So 1 minute, Nitin Kadam sir wants to give more clarity.
Okay.
My question is that
Sir, can you hear? So 1 minute. Sabkal sir, can you hear us?
No, ma'am. Rita ma'am, we cannot hear.
We can hear you, but the one person who is speaking is not.
So would you like?
Yes, sir.
So if you can come here.
Sir, I'm Dr. Nitin Kadam.
Yes, please, sir.
A very good presentation by you and Darvi sir. My only concern is that, sir, because in our setup, in our universities, we have some focus programs. By say like this multidisciplinary, the concern is whether we may lose our focus on our programs. Say like in MGMIHS, there are few focus programs are there. And if we say dilute with other programs, so what's your opinion about this?
Sir, these focus and well established and well accepted programs will continue as it is. Rather, they will become more enriched when they get sort of more inputs from different discipline. But otherwise, they can be continued as flagship programs, and without disturbing them, one can always create additional areas of excellence. Like now, IIT Kharagpur offering management program, agriculture program, medical college, and law also. So basically, IIT has not diluted the program of their BTech engineering, but they have added this and created BTech with LLM. So this is the good combination that has come up because of this combination. But we have to maintain our core competency intact. We can rather enrich it, and we can have more what you call programs in related field or diverse field as well. But definitely, if you see, sir, across whether it is now Purdue University professor is going to speak, so they have n number of programs which are diversified. Like physics was there, but now physics has converted into material science and engineering physics. So physics program is as it is, but it has added the new dimension to study and research of physics.
Yeah, so probably this UGC has picked up this idea from the universities abroad. But the difference between the universities abroad and we are they are the profit-making universities. And we are not that much financially comfortable as far as finances are concerned. So we have some focus areas or we have some strong courses. And if we start to say adding up the courses, and if these courses are not say financially viable, I think I feel that our main focus area may divert. That's one thing. And secondly, sir, as you said, what we can, if we want to say expand something like that, or we want to go to multiple things like MGM IHS, so we can think about going into the medical, engineering, our collaborations, and with the basic sciences, so something like medical physics or the nuclear physics or radiation physics. That type of expansion will be useful for us other than going into the bachelor in the history or BA or maybe the economics.
Yes, very correct, sir. Multidisciplinary education is definitely giving this option of expanding in your related fields and also making your core more enriching. But of course, it is not necessary that one has to enter into a totally different field, like opposite fields, which has no relevance. So they are not saying so. Basically, we have to have the institutional development plan for academic expansion. And academic expansion should have focus on our own competency, and so that the related fields like IIT has started, sir, biomedical engineering also. So engineering was there, and IIM, AIMS and IIT Jodhpur started medical technology. So basically, we can really enrich our own field, but in a related field, but not absolutely what you call opposite or totally new field. So I agree to your point that we should not dilute our own competency or own areas, and then we can also have more related areas of the fields.
Sir, just to add to your answer, multidisciplinary at present, what is presented in national education policy and being implemented, that is for UG program only. The specialization will not remain like that, and the multidisciplinary super specialization and all that in that particular discipline, all that will be remain there.
Correct.
But at UG level, the core subject and the electives and the all-round personality of the student with the holistic and the education and the vocational education, that is imbibed at the undergraduate level. The postgraduate level and the specialization, that will remain. Sir, please.
Yes, sir. One last thing. While expanding, we'll have to go very, very cautiously. And I think, as you suggested, we must have our development plan, and then we will have to go ahead. Because what policies they form, and even at present, what is the implementation going at the ground level in the government level, they're totally different, absolutely different. Just like we speak about the autonomy, but I think almost all our head of the institution, including dean of the medical college, they know how much autonomy he has. Because we talk, the policy talks about the autonomy, but we don't have much autonomy. And usually these policies in our country, it's very difficult when they will take a U-turn and when the policies will change. It's not a consistent for 10 years or 20 years. So we have to be very cautious about it because we are self-financing university. And once we take one step, then probably it will be difficult for us. Thank you very much.
Yes, surely. That is a great point.
So would you, Sapkan sir, would you like to take the other question of Dr. Swati Mahajan from MGM Medical College, Aurangabad, as to how to establish a center of excellence and where is it to be registered?
Well, actually, Center of Excellence is to be established in the university itself. There is a mechanism along with legal framework. Center of Excellence should have very clear preamble as well as objective in a specialized field. Say, for example, as I given you few areas of like nanotechnology, nanoelectrics, or now coming up as alternative fuel, hydrogen fuel. So Center of Excellence is to be established as department, but having multidisciplinary approach. So Center of Excellence, for example, we have department, then we have autonomous department, then we have empowered autonomous department. And Center of Excellence is, of course, in true sense, it has to be excellence in the chosen field. And of course, that center should be able to drive not only the research, but also technology development and incubation and of course transfer of technology. So Center of Excellence should be in true sense excellence, which can be established in the university as center itself. I mean, we don't have any restriction in establishing Center of Excellence in the university format.
Yes, sir. And I think, sir, UGC also has given some guidelines of how to establish the Center of Excellence.
Oh, yes, they have. Actually, UGC has given the guideline for Center of Excellence as well as your autonomous department, and recently Research and Development Cell also they have given the guideline how it should be there and its functioning and its desirable deliverables. So that is also given. See, UGC also sponsored many times Center of Excellence. So on the similar line, we can also establish in the university, either with the help of university, I mean UGC, or we can have it on our own as well.
Thank you, sir. Anyone here in the audience, if you have any questions? Yeah, Anil. Would you like to come here and ask?
I'm Prithviraj Gaikwad from MSc Genetics. So my question. So currently there is news on master's degree being replaced by 4-year bachelor program. Would having a 5-year MSc plus PhD degree be helpful in such a scenario?
Okay. See, the undergraduate 4 years degree is always there in professional programs like engineering, medical, and all these things. But what they are focusing is 4 year, that is 3 years UG is to be converted into 4-year degree program with the 4th year as a research component. See, they have given two options. One is 4-year degree program with research component. One is integrated, say 4-year degree and 1 year MTech, 4-year degree and 2 years MTech to go to PhD. But now with this BTech program, going to PhD is there for long in IITs. After BTech also one can go directly for PhD, provided they have to complete lot many credit work. I mean credits they have to earn related to their research topic. So many times also in US university, people get admission in MS first, but after 1 year they get converted into PhD program. So they save time, and directly after BTech program or undergraduate 4 years program, one can join for PhD. There is no doubt, provided they have given some conditions like undergraduate they should have so much CGPA. Then there are some conditions that they should complete lot many credits, and then only successfully after defending their what you call competency, then only they will be registered for PhD. It is not directly admission immediately after 4 years you get into PhD. So there are criteria to fulfill to be a research scholar. Thank you.
So actually my question is like if we have 4-year bachelor program which allows us to go for PhD, so would that not like reduce demand for a master program altogether? And if we are integrating masters with PhD, then will it not reduce demand for it completely?
Well, as I mentioned that one has to plan his career path based upon talent and interest. Whether it is saving of 1 year or reducing the demand for master. So people don't go for PhD unless it is either their interest or their career planning. Most of the people after graduation, they take up the job. But few go for MTech. It is always advisable to go for MTech before PhD because they understand the concept in depth, and they have some 1 year of project work which will enhance their research skill. But however, this is not only the option. They have created yet another option of 4-year degree program which they can become only eligible for getting admission in PhD. It is very tough to get into the registration of PhD after graduation unless you fulfill your competency. So it will not reduce the demand for master program, and those who want to do master need not be necessarily going for PhD. They can, after their MTech also, they can go for corporate sector. And I would like to add here, most of the corporate sectors are now picking up PhD as their chief executive officers. That means they want a PhD who have a different mindset of approaching the problems, developing the business, and also critical thinking. So these are the aspects which are coming up through the not only typical research, but research ability and research skills.
Thank you, sir. Also, like, what would be the collaboration mechanism for the same? Since we are forming collaborations between institutes or let's say research centers, for instance, what would be the mechanism? Like, how would this happen, and what would it translate into for students?
Yes, actually, we have to draft a proper mechanism to share facility, faculty, objectives. That any collaboration comes by mutual interest and sharing aspect. So if one institute is good in one aspect, having strength, and second institute is having another strength, so they can share this strength so that they can really optimally utilize their resources. And hence you can always identify the areas of your need which can be fulfilled through this MOU. and then you can enter into MOU with not only other institute, but also with research organization, industry, society. You have to identify the partner for collaboration who can fulfill your needs.
Okay, thank you, sir.
Thank you.
Okay, sir. And sir, after this, we'll be having a 10 minutes tea break. It's arranged outside, so people who are interested can please go and have tea.
Yeah,
So you can come. So we have another question by Dr. Ramani Yadav, sir.
Good afternoon, sir. I'm Dr. Ramani Yadav, Technical Director of Comics Research Center. It is one of the excellence centers of NGMIHS. My question is, sir, the national education policy is trying to restructure the education as a multidisciplinary. Do you think this restructuring is also required at the school level so it can match with higher education?
Because once you take center stage, if you're really going to take center stage and say, I'm the man, or I'm the woman, you know, that's not going to work, because no one's going to want to work with you if you don't give them credit for what they're doing. From there, I went on to work as a postdoc at Bell Laboratories, which was part of AT&T time. And I spent 2 years in Murray Hill, New Jersey, a very famous. And there was a hood and a lock-in amplifier, and he said, build a lab. And you got 2 years to build the lab, get the data, go get yourself a job. So this was intimidating, but I had help because I had people around me that were real experts. And so we could build a lab, we could build a research program, and we did so. Along the way, learn new skills, learn new physics, learn chemistry, all these things, because I'm talking to people from different fields daily. And I think that matters, right? Being in the same place matters because you have to be able to exchange ideas. When I finished at Bell Labs, I started as an assistant professor at Louisiana State University, as the person who introduced me said quite nicely. And I started as an assistant professor and started a laboratory there. And we started looking and trying to build interdisciplinary material science program at what's known there as LSU. Louisiana is in the most southern part of the U.S. The weather in Louisiana is very much like the weather here in Mumbai. So I'm kind of used to the hot, humid weather for many years that I've lived there. And we were able to do that. And I was able to connect up with a young chemist, a young solid state chemist, who was willing to work with me. And that was really important because, you know, I'm not an expert in growing crystals, measuring their crystal structure, and doing all those things that solid state chemists do so well. And she wasn't an expert in making measurements on these samples and pulling out the interesting physics and science from those materials. So it was great to have her there. And then to say, okay, I can't be an expert in every measurement type. I can know what the measurements pull out, but if I want to do something that's unusual, I need an expert in that. Because if I try and do it all myself, it's going to take too long. I can't compete. So those elements came together and we were able to pull some things together that got me through tenure, you know, through associate professor, through full professor. And then when I was full professor, we had enough established at that university where we could develop a research program in what's called neutron scattering. And so we made a proposal to the Department of Energy for a large grant that involved 4 different universities in Louisiana to explore materials using neutrons. Now, you can't just have neutrons, right? We had to travel to the national facilities where we use neutrons to study materials. And there again, we had to rely on the experts that were there and be willing to share credit with people at what is Oak Ridge National Laboratory.
And we were quite successful at doing this. We had a wide array of programs, and I played the role of principal investigator. And part of that role, as you probably, if you've been in administration, you know, is herding cats, because faculty want to go in every which direction, and they have their idea about what's best, and you've got to be able to say, okay, that's nice, that's really not good, but we have our goals of this program. If we don't stick to the goals of this program, then we're not going to get renewed, because we have masters, right? We have to talk to the boss. Our bosses were the program managers at the Department of Energy. And we told them, we're going to deliver this. And so I use that as my method for corralling people and saying, no, we're going to work as a team. And if we're not working as a team, then we're not going to be successful. And again, I think these elements are really important when talking about doing interdisciplinary science. You have to have leaders that are, you know, willing to work with people gently. Get them to work together. And sometimes that means going in and saying, wait a minute, you can't publish this paper without this person as a co-author, because you relied on their work to get it done. And you have to be willing to do that even though people are angry or wanting to step up. So leadership matters in that case as well. I guess I did that okay, because then they hired me as the department chair at the Department of Physics and Astronomy there. And I learned tremendous amount as a department chair. And then I had a wonderful opportunity a couple of years ago, and that was to join this university, commonly known as IUPUI, which stands for Indiana University, Purdue University, Indianapolis. And I joined as dean of the School of Science. And that was a wonderful opportunity. I couldn't turn that one down. So we moved. I think there's a chart here showing. Yeah, the map of. And you might notice that we have a rather long acronym of 5 letters. And it's a rather long name, Indianapolis University. We are the combination of 2 Big Ten universities. So Indiana has, right, on their map here, Purdue University is sort of to the northwest of Indiana. Indiana University of Bloomington is sort of south of Indianapolis by about an hour's drive. They're both out in rural communities, but there was no big university in the city of Indianapolis. And so the state decided that they were going to start a university in 1969 in Indianapolis to serve that community. There was already a medical school that was starting to build up there, and they decided they were going to build a university next to this medical school, which is a wonderful idea. And so to do this, they brought together their 2 universities that had programs in the city already to form this university. I like to joke that, you know, this university was built to maximize complexity. And, you know, that's kind of true. Every day we deal with this complexity, but we get through. And it's really good for our students because it brings these 2 universities and their strengths together to be one. And so it really does work for our students. You may know Indianapolis if you like car racing, because we have the Indianapolis 500 happen every year, and that draws something like 300,000 to 400,000 people to those grounds to watch the auto race. I haven't been there yet, but it's something I definitely have to do. But here's the center of our city. You can see it's a beautiful city. It's a mid-sized city, so it's livable. Our students can afford to live there. Our assistant professors can also afford to live there. It's not like you're on the East or West Coast where things can be very expensive. So we can keep our tuition and our fees and living expenses down for the students, and that's a great selling point. So what they formed is Indiana's premier urban research university. And we have all of the health schools right on our campus. So not only is the medical school across the street from us, but we have the dental school, the nursing school, social work, you name it, it's on our campus. And that again brings up lots of opportunities for us for this interdisciplinary work. We take advantage of that. Our degrees are awarded either by Indiana University or Purdue University. And we have some, we have some nationally ranked programs and we're known for particular things, including in sustainability. So we've taken it upon ourselves to be leaders in sustainability, which is really important when we start talking about climate change and the effect on us. If we don't move towards sustainability and trying to mitigate the effects of climate change, there's going to be real problems. You can see that the university has quite a lot going on with over $500 million annually in external research funding. Much of that is at the medical school. We have almost 30,000 students, 109 research centers. Many of these are interdisciplinary research centers, and students from 142 countries, including a large population of Indian students. We have a large number of degree programs in 17 academic schools, of which science is. So that's us. Okay. And we just built a couple of beautiful new buildings. This is the Science and Engineering Laboratory building. And this building here, we just opened in May of 2020, which is we call Innovation Hall. And when we opened it, they gave me this nice key with a ribbon on it. And so now if you're looking for it, I have the key to innovation. Little joke. So this is us on our campus. This building was built with interdisciplinary science in mind. We have clean room facilities here. We have maker spaces. We've got laboratory spaces that can be used in many different ways. So we have space for biologists, chemists, engineers, to do nanoscience and other areas, but the clean room was built specifically to address nanoscience. And so when we talk nanoscience, though, I'm not just talking engineering. We've got chemists and biologists interested in nanoscience, the use of small particles, either for things as strange as drug delivery, treatments of cancer, and even semiconductors, right? So it's really all varied depending on what you want to use those tools for. I'll tell you a little bit about my school. You can see we have some standard departments: biology, chemistry and chemical biology, computer and information science, earth science, which hosts our geology and environmental science areas, mathematical sciences, physics, and we also have psychology in the School of Science. And that gives us a real advantage, by the way, because the psychologists, they're neuroscientists, and they collaborate heavily with the biologists in those programs. And that allowed us, because we aimed in that direction and said, okay, we've got a medical school. That medical school has a neuroscience program. They built a building. We need to build a neuroscience program as well. And so we do. We have it. It's the combination of those two. And we're allowed now, or we have a very strong BS program, bachelor's program in neuroscience. Some of the best students in the university at the bachelor's level are in neuroscience. They are attracted to us because it's an unusual program that trains them in a way that is not typical and trains them with both the psychology and the biology together. And that's something now, because we've been successful at nucleating these interdisciplinary programs, we now can attract students to these programs, these degree programs, we can offer that other places can't. And I think that's a strength of this. The other one that's like this is our forensic science program. Now, forensics is really the combination of biology and chemistry. And again, if you don't have biologists and chemists that are going to work together and form this, it doesn't work. But we were able to do that, establish the programs, establish go a bachelor's and a master's program in forensic sciences. We have the only forensic science program in the state of Indiana, and it's one of the only ones that's fully accredited in the US. So you can see we've got over 3,000 students in the school, and as she said in the introduction, almost 200 faculty. Here's our research funding. We have about $13 million in the School of Science each year in research funding. Our faculty do really well in terms of writing grant proposals and pulling in those funds. Something we're proud of too is that our students not only do well in school, but we prepare them well for the careers outside and for going on to graduate school. So we do a survey after each graduation of the students. And at that time, we get report that 87% of them are employed or know what they're doing in terms of continuing education, being accepted in graduate programs quickly after graduation. Our interdisciplinary research programs also open up real opportunities for undergraduate students and our graduate students, because we have programs where there are collaborations across to the medical school and to the School of Science. Now our graduate students and our undergraduate students can work in the research laboratories in both. And they're welcome, our undergraduates are really welcome in the School of Science. In the School of Medicine. And that's a tribute to them, that they're willing to take on these undergraduate students, train them, and get something out of them as they go through and help their research programs. And then when the students say want to go to medical school, they have that training, they have that in their resumes to help them out. Okay, and I think that's an outstanding feature if they do research like that. So we welcome undergraduates into our laboratories to work with our graduate students and our professors. Some of the things that we have also in terms of preparing students for their careers is we have our preps office, which is our pre-professional career preparation. And so what the advisors there concentrate on is working with the students to help them define what careers they might consider, help preparing them for their first interviews, preparing resumes, preparing for professional exams if they want to go on to professional schools. All of this is done in our preps office and is available for the students from day one up through when they graduate. So we have a lot of, sort of, besides the usual advising and tutoring that goes on, we also concentrate on preparing our students for those things that you don't always think of that are really important when they start thinking, okay, I've got to walk in an interview. What am I going to say? How am I going to sell myself? What is the important thing that, the person I'm talking to wants to hear? Our graduate programs are quite strong and they really help, right? You can't have research in a university without graduate students. It just doesn't work. It doesn't work well. And so we have very robust graduate programs in all of our departments, as well as the master's students in forensics. So you can see some of the numbers here. And in particular, our computer science program is growing quite quickly. So let me tell you a little bit about the research in the different departments. And so you can kind of pick out where this interdisciplinary work is going on. In biology, we not only have our bachelor's degree, but we also have a couple master's degrees, one which is a thesis master's and one which is a pre-professional master's. This is aimed at students that want to go to medical school and aren't quite ready for it. And so it's a one-year master's program that prepares them to apply to U.S. medical schools. And we also have our PhD in biology, which is quite strong. And I'll point out that we're open for possible collaborations in terms of degree programs. We have several set up with different institutions, particularly in India. We have 17 tenure-track faculty in the department, and we have state-of-the-art facilities, biomedical research labs. We have plant biology labs and a greenhouse on top of our building. And we also have 11 biology teaching labs. Biology is our largest major. We have over 600 undergraduate students in biology, and we have a nationally ranked graduate program with 56 graduate students. The funding that the faculty receive is mostly from the National Institutes of Health, as well as National Science Foundation, a little bit of Department of Defense, DARPA, National Institute of Justice, and some others. And our faculty, for 17 tenure faculty, they produced 50 publications in 2021, which I think is really outstanding productivity. So I pointed out the neuroscience, right? So in terms of interdisciplinary programs, this is one of our highlights. And it couldn't exist without that work across the departments and into the School of Medicine. So we have work going on in sensory neurobiology, in particular hearing, developmental neurobiology, epilepsy, neuroregeneration, and hydrocephalus. That's the part that goes on from our biology faculty. There's more I'll get to when I get to psychology as well. The forensics and genomics research that goes on, there's much of it going on in genomic phenotype correlations in insects. That's a really interesting program. I'll say more about that later. And also understanding genes that are responsible for human physical appearance and traits. Now that's done by a professor that works from biology in our forensics programs. And you can see why that would be important in forensics. If someone leaves some DNA somewhere at a crime scene and you want to know who's been there, you have their DNA, but they may not be in a database somewhere. But can you give us clues from their DNA is what you might look for. So if you had a way of understanding how your genes determine your appearance, that would be important. Now that's not so easy, right? And Susan Walsh, Professor Susan Walsh's program is centered on exactly that. And that really attracts students. They love that program. They're really attracted to that one because they can really get their head around, their mind around what that is. The mechanism and treatments of Down syndrome and genetic disorders. We also have a new assistant professor who studies diseases of the pancreas. I'll just let you read some of the examples of the sponsored projects that we have. And you can see they're from different sponsors, National Institutes of Health, Department of Defense, NSF, and DARPA. Chemistry. Chemistry is one of our strong programs. These are ACS certified programs, bachelor's in chemistry. We also have our master's. We have a thesis and non-thesis options. We also have options with internships where the students work in a company. That's really important for us because we're in the middle of Indianapolis where there's lots of industries, including the pharmacy industry. Right, pharmacological industry. Lilly has their headquarters in our city. Roche is in our city. There's several other smaller pharmaceutical companies in our city. And so there are students that are involved in chemistry that want to go off in that direction. And we have other areas as well, other industries too, where our students go and do internships. And then we have our PhD in chemistry as well. There are many opportunities for possible collaborations as well in our chemistry program. This I like to show students. It says that there are great careers in chemistry. There's a tremendous amount of money in the chemical industry in the U.S. and elsewhere. It's one of the top businesses around, and chemists do well. They earn a lot of money, and they're in high demand. So we have 12 faculty in the chemistry department, and the research strength is really in analytical chemistry. There's nanochemistry and biological chemistry as well. We have 300 undergraduate students and 38 graduate students in the program. Their funding comes mostly from the National Science Foundation, and they also get NIH money. This is from the forensics program from the Institute of Justice, and also some DoD money. And this money supports research in analytical chemistry and chemistry at the biology interface. Here's a little more about our research programs and projects. Again, detection of analytes and chemical measurements is where we thrive. Monitoring drugs, chemical and biological warfare agents, nanomaterials for energy and sensing. Of course, if you're going to do work like that, it has to be interdisciplinary because you're dealing with a tremendous range of things, from synthesis to measurement to trying to produce devices. It's hard for one person to try and be an expert in all of that. You're much better off having people that are experts in part of that, working together to build programs that are successful. And then chemical and biological interface. I'll let you go ahead and see what we do there. Computer science. Computer science is naturally interdisciplinary because it really has to do with the tool, which is using computers to do stuff, right? And if you're in a school of science, then you want to be able to do science. And so you need computational science, and you need computational scientists who are working with computer science. And if they work together, then they can push those tools to the maximum and learn things that others cannot. So in our computer science program, we have BS, MS, and PhD programs. We also have an MS in data science. And data science, you probably realize how important data science is. Our telephones, for example, right, our cell phones collect enormous amounts of data, and it goes off to all these corporations that collect it. And then the question is, okay, how do you sort through and pull out the important parts? How can you learn from this enormous data set? That's quite a problem, and we train students to work on those problems. Every industry is going to need data scientists in the future. That's going to be is a real growth. Of course, computer science, people will tell you, is going to continue to grow. Everybody wants to do artificial intelligence, and that's an area too where we excel, and we have undergraduate programs and graduate programs, and of course, the jobs are there and the salaries are quite high. We have 16 professors and 3 lecturers in this department. We have 425 bachelor students and 170 graduate students. We have many graduate students from India in that program, and we will welcome more. Again, they do really well in funding from both federal and private organizations. This includes the NSF, the Department of Homeland Security, NASA, National Institutes of Health, etc. So the research programs there are in intelligence systems, and that means, as I described, data mining, machine learning, and artificial intelligence. And the key, again, is to get these scientists, computer scientists who are expert in these methods and developing these methods, to work with scientists in other fields so that the scientists have access to the newest, best tools to be able to beat out the competition. If you don't have people that are willing to work together across those borders, it doesn't work. We also have groups in software engineering and distributed systems, high performance computing, testing, high assurance systems, groups that are concentrating on visualization and graphics. Again, if you've got this larger data set, how do you visualize it? How do you pull out the important information and then present it in a way that can be understood? Networks and security, of course, this is all very important for trying to live in the world that we do. So we have many sponsored projects, a couple of them that highlight some of the interdisciplinary nature. We have a professor or a group that's studying quantitative approach to the understanding and distribution and diversity of key water-form minerals on Mars. So if you're going to spend a few $1 billion getting a rover up on Mars that can drill into rocks, you're going to want to know where to look. And so developing ways of deciding where to look is important. And of course, you need somebody that understands rocks and water, not just computer science to do that work. And also the second one that I have highlighted here is real-time algorithms and software systems for heterogeneous data-driven policing of social harm. Now, this one is all about policing and, being an urban university, it's where do you concentrate your police? How do you decide where crime might occur? And how do you deploy then your police force in a way that would be in the right place at the right time? And also, how do you make sure that you're not discriminating against people of different origins when you do such a thing? So all of that, right? You can't, if you're going to do that, well, you need a psychologist that understands those things, because computer scientists physicists don't know that either. But you need someone who's an expert that understands that to work with computer scientists to produce something of quality. Department of Earth Sciences, as I said, that contains both our geology and environmental sciences. We have a couple bachelor's degrees. We have an MS in geology and a PhD in applied earth sciences. There's lots of jobs for environmental scientists and geologists, and they earn really good salaries as well. Again, we're open to possible programs that are collaborative. In this department, we have 13 faculty. Our research strengths are in geochemistry, environment, and human health. Again, right, once you write down something like geochemistry, it automatically says there are people there that are going to collaborate, because they have to know geology, they have to know chemistry, and they have to be able to work in both worlds. Environment and human health, that's not often found in an earth science department, but when you start talking about lead in an urban atmosphere, that is right. In Indiana, we have old cities that have lead pipes and lead paint everywhere that are used for a long time. And the question is, okay, we have children growing up in that environment. That's an environment. It's an urban environment. And so we study that. We try and understand where the lead is and how to mitigate these things, particularly in areas where there are children growing. We've got lots of facilities. There are about 100 undergraduate students and 30 graduate students in these programs. And the funding is from National Science Foundation, NASA, Department of Agriculture. And this supports research in petrology, geochemistry, hydrology, and climate change. And of course, those are really tied together, hydrology and climate change. And that is one area where we're going to be concentrating much in the future. And this tells you a little bit more about each of these areas. I don't want to hold you too long, so I'll continue on. One of our interdisciplinary programs is forensics. We offer BS and MS in forensic science. The careers that the students go on to after getting these degrees are in the private sector. They're in government forensics labs, and the starting salaries are upwards of $50K per year. There are also lots of opportunities here for possible collaborations, either for undergraduate or graduate program or combined program. We have, it's a small department with 4 tenure track faculty, 2 lecturers, and 1 academic specialist. We have forensics biology, forensics microscopy, and forensics chemistry laboratories. Our program, as I pointed out, is one of the only accredited forensics programs around. And we have a few MS students and lots of bachelor students. The students in the U.S. the kids in the U.S. watch a program called NCIS, and I'm told that there's a similar program in India. about forensic scientists and what they do in solving crimes, and they're always the hero at the end. So students always are attracted to this program. So it's always good to have, Hollywood, in our case, advertising for what you do. In terms of funding, they're funded by the Department of Justice. There's lots of programs there, the National Science Foundation, NIH, DoD, and the National Geographic Society. Here are our 4 professors that work in this program. Dr. Nicholas Maneke works on drug analysis and toxicology. He's trained as a chemist, but when you get into these fields, you're obviously collaborating with biologists and people in medicine. Dr. Susan Walsh, she's the one who studies genetics of human physical appearance and ancestry prediction based on DNA. Dr. John Goodpaster, he's an interesting fellow who likes to study explosives. And so he looks at both things like how dogs determine whether they're smelling explosives or what some people put in explosives. And so they want to know, okay, is the dog sensing really the thing that's going to explode, or are they highlighting these additives? Because if they're highlighting the additives and you go looking for explosives, but they don't have the additives, the dog's not going to find it. And so he has studies like this. He studies the residuals that happen after explosions, all sorts of fun stuff. Again, the students love this, right? You talk about exploding things, they tend to show up. And Dr. Christine Picard, she's our forensics entomologist. She's the one that has her program where she studies blowflies. And one of the programs that she has that's really interesting is that she sends these blowflies out in the environment. The blowflies sense the environment, you capture them back, and you study what's in their stomachs. And so now you know what's out in the environment. And so you're using chemical methods, right? A lot of mass analysis to understand what is exactly in the stomachs of these blowflies. And she's now got a grant from the Department of Defense to look for chemical warfare agents. And the idea is if there's war and you suspect that chemical warfare agents have been used, you don't want to send your soldiers in to go find out, did they use chemical weapons? So what do? We use the blowflies. They go in, they sense the environment, they come back. If you look in their stomachs and you find these chemical weapons, you don't send your people in, you know it's been used, and hopefully you can bring some justice to it as well. So I thought that was really creative use of chemistry and biology and real applied. Our Department of Mathematical Sciences, we also have interdisciplinary work going on there. We have programs like actuarial science, applied statistics, applied mathematics, pure mathematics, and even the teaching mathematics in this department. We have master's and PhD programs. Again, in applied statistics and math, we have math teaching, pure mathematics. And one that's growing quite a bit in popularity is the data science program running out of mathematics. Again, if students come in for a master's program and they have good computational and statistics skills, they're really good for this program. And there's a lot of demand for those students when they finish. We also offer a PhD in biostatistics and a PhD in mathematical science. Our students do really well when they graduate with math degrees. They work at financial institutions, tech companies, insurance, healthcare, government agencies, and mathematicians are really good at solving problems, so the students are really good salary. We have 27 tenure-track professors in the department and 14 full-time lecturers. We have 114 undergraduate students, 24 master's students, and 30 PhD students. In terms of funding, most of the funding comes from the NSF. There's one NIH grant that's a collaboration of a mathematician and a biologist, and the Simons Foundation also supports mathematics. And you can see the range of research areas that go from real fundamental mathematics that I couldn't tell you what they are because I've never taken classes in that kind of mathematics, all the way to really applied work and collaborative work that they do. I told you a bit about our neuroscience program. That we offer only a bachelor's right now in neuroscience, but if students are interested in neuroscience, then they would go into the biology or psychology programs. Most of our neuroscience students are double majors in biology and psychology or math or artificial intelligence. Many of these students, these are some of the, by the way, best students in the university who get into our neuroscience program. Many of them go on to medical school. They use that as a launching pad for medical school. The faculty, we have 20 faculty involved in neuroscience across 3 departments, biology, math, and psychology. We have 232 majors, and the funding comes from NIH, NSF, and some local money where there's an Indiana University program on addictions grand challenge. And so our psychologists, in particular neuroscientists who study alcoholism and drug abuse, particularly in animal models, are supported by that program. The students go on to great careers in medicine, research, pharmaceutical companies, biotechnology, therapy, private foundations, government agencies, and again, there are really good salaries even at the BS level. The biggest program there is addiction neuroscience, but we also have developmental neuroscience and computational neuroscience. Again, you can see you can't do these without collaborations, without interdisciplinary science. Lots of sponsored projects, diabetes and eye function, the impact in early life of environmental conditions on drug intake and the related hydrocephalus, and psychomotor stimulant drugs, responses to psychomotor stimulant drugs. Physics is my home department. This is a small department. We offer bachelor's, master's, PhDs. Physics students go on to get jobs. There are no unemployment physicists that I know of. They all do really well. And there's lots of opportunities for collaboration here. So some of the details, we have 13 faculty members, lots of research space, lots of high quality facilities as well. We have 40 bachelor students and 20 PhD students, 4 MS students in physics. Their funding comes from the National Science Foundation, NIH, NRC. Again, you might ask how a physicist gets money from the NIH. It's because they're doing biophysics and they're doing collaborative work. Most of the research programs are in condensed matter and biophysics, so we study biological membranes, solid state NMR and X-ray scattering to study them. Advanced microscopy. So this is a young fellow who's doing really well, trying to increase resolution. He's working on using imaging of rat brains while they're doing things. So, mounting microscopes on rats' heads and collecting enormous amounts of data as to what's going on in the rat's brain, and then working with a computer science. So we have some other programs that are more along the lines of fundamental physics. Our Department of Psychology is quite strong. We offer bachelor's in psychology. We talked about the neuroscience. We have an MS in industrial and organizational psychology and PhD programs in applied social and organizational psychology, clinical psychology, and in addiction neuroscience. Our students go on to many varied careers in, from all of this wide breadth of things that they study, and they do quite well as well in terms of their salaries and careers. We have 25 faculty in psychology, large number of students, 706 undergraduate students, 182 undergraduates in the neuroscience program, 4 in the master's program, and 52 PhD students. They get a rather large amount of money from the National Institutes of Health, including training grants for students, National Science Foundation, and the IU Grant Challenge. So some of the areas and research projects in clinical psychology, extreme emotional states and substance abuse. Again, that same theme that we have running throughout is substance abuse. And so we have many researchers working together on that. Pain and functioning and influence of psychosocial factors on health outcomes. So you might be realize in the U.S. That depending on your demographics, you get different outcomes in terms of health. And understanding why that occurs and how to mitigate that so that everybody gets treated well is important. And even in terms of sex or gender, women aren't believed when they come in and say, I'm in pain. A man comes in and says that in pain, they, okay, you're a man, you probably put up with a lot of pain, so, it's something serious. A woman comes in with pain, they don't get treated the same. Understanding that is really important, and mitigating that is also important. So we study these things in psychology. We have in our applied social and organizational psychology and IO psychology, stigma identity, persuasive appeals, and health communications that relates back to the health outcomes. Interventions promoting marginalized persons, again, trying to understand why people treat each other differently, and gender and equal opportunity employment also couples in terms of the addiction neuroscience, that couples right back into the neuroscience discussion I just had. And so we see the same types of things like sex differences in the response to stress and alcohol, neurophysiological basis of cognition and addiction and schizophrenia, and brain and behavioral impacts of prior drug and heavy metal exposure. Again, we have environmental scientists studying lead exposure, and then we have psychologists that study neuroscience and their work in the same area. So there's lots of places to tie in. Now we have people that can work together to write grants that other places can't because they're not working together in this interdisciplinary sense. There's a lot changing on our university. I won't go in deeply on this, but we're undergoing some rather fundamental changes as we grow. And this is really going to bring opportunities for us in the future to continue on this. So I think I'll leave it there. I appreciate your attention. If you have questions for me about any of the research areas or our education programs, I'd be happy to answer. Thank you so much.
Thank you so much, sir, for sensitizing us about the interdisciplinary programs and the activities at your school. And it was quite interesting, especially to know about how the DNA at the crime scene can be used. This time, trying to see how we can predict the physical appearance of the person who has committed the crime. Thank you so much, sir, for that. I would just like to inform you that we have in this program, it's a hybrid mode. So we are there's a physical presence here, but we also have institutes from other locations, Aurangabad, Nanded, and Noida, who have joined us. So, so I would just request if anyone has questions, you can just put your questions in the chat box or unmute yourself and ask the question.
Welcome. I didn't realize that an audience is always this.
Any questions?
I guess it's been a long day.
Now, this particular institute is at Navi Mumbai. We are also having the partner institute who has joined this particular program at Aurangabad campus. And that is particularly the engineering, physics, and chemistry. Here the specialization is the health science and allied branches for at this university, where the other the engineering and the other science branches in the various streams, those will be there. So their students and everyone is listening to you. So those particular, so Sapkar sir, you want to interact quickly?
Okay. At the outset, I welcome Professor Tusa. Yes, yes. And what we have been discussing, the truly interdisciplinary education we could see from this combined of Indiana University and Purdue University taking together the programs. And if in MGM University Aurangabad, we also have programs related to forensic sciences, biophysics, psychology, geology, applied geology, and of course, engineering, all programs in engineering, particularly computer science, IT, artificial intelligence, data science. So basically, I really, in fact, I wish that you also visit our campus in Aurangabad so that we can have more meaningful areas of cooperation. But nevertheless, it is a good opportunity that we can join hands. We have started integrated program in physics, biophysics, and material science, as well as medical technology, which is a combination of engineering and medical. So definitely, I could see some good areas of research, particularly forensic sciences and applied geology. Definitely, we can not only have the collaboration for conducting joint program and also research, but also we can have exchange program of our faculty and student provided within the framework. So we can, I look forward for collaboration with your university, particularly School of Science. We have School of Legal Studies, School of Applied and Basic Sciences, and School of Engineering and Technology. So look forward for more meaningful cooperation for research and interdisciplinary education. Thank you.
Thank you. Thank you, sir. Now, one interesting point. Dr. Raje is here, whose brother have studied at our engineering college, who is working at Indiana University. Indiana and Purdue, two joint university. He has also come to visit our campus. On behalf of all of us, I welcome you also, sir. So surely there is already the liaison in between Purdue Indiana University and this particular campus, and we will surely increase this particular liaison in future. We will have a discussion, more interactions, and we will see. There are many MSc students who might have seen the various areas that you have shown, and somebody who are interested, they may also do the correspondence and everything. So all that will go on. There are various types of the programs as per our National Education Policy 2020, and particularly twinning of the program, dual degree program, and the joint degree programs. These are the three types of collaborations in between the universities during international collaborations that we can take place. So we will explore all the possibilities, and particularly the two areas that you have mentioned, and just now our IPC coordinator also mentioned, particularly the forensic medicine and the investigative science, and also the other area, the neuroscience and the genomics. So we will surely explore the possibility and joining the hands in the area of research also, because basically your strong background is the research, it appears, of your university and the collaboration in that particular area. Yeah. One question you want to ask? Yeah, please.
You have Dr. Raman Yadav, sir, who is in charge of the Incubation and Innovation Center and Institutions Innovation Council.
Sir, good afternoon. And after your presentation, what I understood, this university is rich and basically it's a research-oriented university. When we talk about the research, of course, the basic and the fundamental research, and we are looking for the collaboration where all the expertise from the university can be channelized for the foresighted program, particularly in the disease area.
If you see this pandemic, nobody was that time aware of it is coming in this way. So if you want such a program in the research, what are the areas can be explored in the future? So this is the one aspect I was thinking. Overall, my expectation in the research is if the university having a number of the research domain, can all the research domain integrate in such a way that they can address the mission project of the university, mission project. One project, there's an integration of all the subjects. This type of model. And the third important side, what is your opinion? If you see the all over in the developing country or the underdeveloped country, the research is not a financial model. So they are not able to generate the finance or from the research field, except the publications, the few publications and the patent and the few technology transfer. How the research can be a financial model if you have a very good infrastructure.
Those are all good points. Sure. I was going to say those are all really good points. And I would say that, you know, it's one thing to bring scientists across, scientists, engineers to your university, but you have to have the policies in place and the people in place that would make that interdisciplinary work happen. It doesn't just happen if you bring the people there. You have to make sure that your policies are in alignment with, and that goes to, you know, rewards of your faculty. That is, you know, when you go and you judge a faculty and say, are they worthy of tenure? You have to say, okay, you know, we know that work was interdisciplinary, that was collaborative work. We're not going to ask if it was a single author publication. We're going to ask the question, what did they bring that was special to this project? And if we can see that they're bringing something unique to the project, then we value that highly. And so I would just say that, you know, as you start thinking about designing things, think about that. I recognize that there are lots of challenges to doing research. And, you know, it's challenging enough, but it becomes even more challenging when you don't have the resources that you would need. So you have to be very choosy. You have to choose projects and areas where you can make an impact. And then you have to celebrate like mad when you make them. Because, you know, they do happen and people are successful. And it's really impressive when they are. I hope that addresses some of it.
Thank you so much, sir. I now request Nitin Kadam, sir. Yes. Felicitate. Okay. So I request Pro Vice Chancellor, sir, Dr. Nitin Kadam, sir, to felicitate Dr. D. Tusa, sir. Thank you. Thank you so much, sir. I request Nitin Kadam, sir, to felicitate our Honorable Vice Chancellor, sir. Okay, fine, sir. So I'll invite Dr. Rajesh. Sir. Thank you, sir. Thank you so much. Yes, sir. Yes, sir.
Good afternoon. My name is Rajiv Rajay. I'm a professor of computer and information science at IUPUI in the School of Science. I also serve as an associate dean, so Dean Dutusa is my direct boss. That's why I'm staying a little bit away from him. First of all, I want to thank all of you for inviting us and giving us this opportunity to present our school. And the discussion was about interdisciplinary projects, right? And my discipline, computer science, is a good example of what interdisciplinary aspects of field can actually have. Computing, all of us know, is very pervasive. Right? All the projects that the dean talked about, I can perhaps pick any randomly a project and show the role of computing in that project. So what is also happening, one of our colleagues just said something about pandemic, right? The pandemic has taught us that a lot of complex problems require a team of experts working together. We just cannot address the challenging problems just by staying in our own disciplinary silos. So interdisciplinary research is going to not only increase, but we will be, as a society, dependent on such research aspects. So I'll tell you two examples of my own research that will kind of tie to the health sciences aspect of it. So when I joined IUPUI 28 years ago as an young assistant professor, I joined hands with a few of my colleagues from computer science department. But then we also had two other colleagues. One was from library science, and the other was our previous dean, who was a biologist. And the project that we did, which National Science Foundation essentially funded us, was to be able to carry out text mining of biological documents. And what we were interested was to identifying hidden relationships by looking at a large amount of text documentation. And our hope was that we could identify such relationships. And then this colleague of ours, Dr. Simon Rhodes, who was a biologist, could actually go and formulate an hypothesis in his lab and see whether that really can hold or not hold. So this is a prime example of interdisciplinary research. The other research project I did with a colleague of mine in computer science, and then we actually had colleagues from nursing school and medical school as part of that activity. And our goal was to create a pervasive indoor tracking system. So we all have cell phones, right? Cell phones have GPS. They do a wonderful job of locating us when we are outside. But if the cell phone or your GPS cannot tell you very well where exactly I am in this room, they try to use triangulation using Wi-Fi signals,